Okay, so here we have that the instructions read solve each system using matrix notation, express the solution set using vectors. So in order to do this, I'm going to start off by writing the system as a matrix. And now what I'm going to start to do is I'm going to do Gaussian reduction, and what I want to make it as easy as possible for myself, but you just have to be really careful. And what I notice is that I'm going to use this middle row in order to eliminate the 3 in the first row, and I'm going to use the middle row to eliminate the 5 in the third row. So in order to do that, first I'm going to multiply the middle row by -3, and I get this here. And I'm going to add this to that top row, and I'm going to get 0, 6, -2, right? When I multiply by -3, oh wait, this is 2. Oh, there we go. I copied the matrix wrong. 2, so then what is this? This becomes 5. There we go. Yikes, that was a close call. Okay, 2 is here, and again, I multiply by -3. This row I added, I'm going to get 5. Okay, we're good now. -2, and then on this side, -6 and 1 is -5. And then the middle row stays the same, 1, -1, 1, 2. And now I'm going to multiply the middle row by -5 in one step, and then add it to the third row. So when I multiply by -5, I get -5, 5, -5, -10. And I add that to the third row, I'm going to get 0, 10, 5 and 5. And then 1 and -5 is -4. And then 0 and -10 is -10. And now I can see that it's sort of not really in order. I would want to do a row swap, and it's up to you when you do the row swap, but I'll do it at the end. I'm going to do -2 the first row, and then add it to the third row, and it's going to completely eliminate the third row. So now I have 0, 5, -2, -5, 1, -1, 1, 2, and then 0, 0, 0, 0, right? Because -2, this second row is -10, 4, 10, and you should see that this, when added to the third row, zeroes out. And then now we see that the third row is a redundancy. You flip the 2, you're going to get this. And now I'm going to make it so I can express the solution set in a nicer way. So I'm going to first divide the second row by 5. So when I divide the second row by 5, or multiply by 1/5, same thing, I'm going to get this, -2/5, -1. And then I'm going to add the second row to the first row to get the 0 here, and then 3/5 here, and then 1 here, and then I get this second row stays the same. And now here I want to look at this, and I want to express the solution set as vectors. It's now in, I think, reduced echelon form, but whatever, it's in echelon form at the very least, and that's all you really needed, but I just made it a little easier. So we should see that this is x, y, z, and then I got this bottom equation says x, or says y minus 2/5 z is equal to -1. So that means that y is equal to -1 plus 2/5 z. Then what I can do is I can rewrite this equation as x plus 3/5 z equals 1, and then I get x equals 1 minus 3/5 z, and then I can rewrite both of these. I could say, and then now with this I can express the solution as a set of vectors. It's helpful if you write it as x, y, z, and you should see that it's the z that's free, right? The constants for x is equal to 1 minus 3/5 z, so it's a 1 here as the constant. plus, and then this is going to be the z part, is negative 3/5. And then you're going to have y, the constant part is negative 1 from here. And then 2/5 of a z. And then finally, there's no constant part for the z, and then there's a 1 for the z, such that z is contained in R, is your entire solution set, this here. And then you're done.